All right. So all that was a review of yesterday. Just FYI. This is the material we're supposed to cover today. We'll see how far we can get. And Dr. Paul West, data structures. Today we're going to talk about compilation. Beforehand, hopefully you've gotten at least the basics of how you navigate a Unix system. Today we're going to talk about how can you set up compilation, and then how can you make it nice and easy for yourself so it's not difficult and hard. All right, Linux. Everything is a file. Okay, almost, but Linux philosophy is everything is a file. You want to write to your screen, open up a file. You want to read the pixels on your screen, read a file. You want to communicate over the network, open up a file. Everything's a file. And it has permissions. That's about it. We got it? Good. Directories are files. I just told you, everything's a file. So a directory is also a file. A directory is just a file that contains other files, or points to other files. When you want to remove a file from a directory, you remove the link to that file. Standard structure. /bin is where your programs are, aka binaries. So notice that CP is in here. DF, echo, ls is another program. And that was when I did ls/bin. A lot of your programs are in bin. That's where your binaries are stored. etc is for your configuration files, or etc. Lib is for your system libraries. You all heard of DLLs and different types of packages that need to be installed. DirectX maybe? DirectX, there we go. So DirectX is a library. It's not an actual program itself. It's a piece of code that other programs use in order to run. So all your system libraries are stored in lib. By the way, there are way more than just a handful of libraries. There are tons and tons of them. Dev is where your physical devices are. Kind of showed you a little bit there. So if you want to open up a read and write to your monitor, /dev. Home is where users' files are stored. Hence /home/ your username contains what you want. Hopefully this makes sense. It's still a standard directory structure. We just call them directories now instead of folders. Because folders always seemed weird to me. You have a folder inside of a folder?
Directory. Big folder.
It's a big, yeah, well, whatever.
Well, it's like a 3-ring binder, and then you put the folder in it.
Yeah, but what if you have 20 folders down? How does that work?
A lot of binders, I guess.
Well, I mean, you just have to have really increasingly sized binder. I mean, come on, guys.
Why don't you get like a 50-inch binder?
50. Let's give it a different name. That's all I'm saying. But you know what? I will give Microsoft credit. I do think the recycle bin does make more sense than the trash, because that is what you're doing. So I'm not completely anti-Microsoft.
Go green.
What?
I said go green.
Go green. You can mount a hard drive so you can read it. If you want to learn how to mount a hard drive from the command line, it's like that. Or you can just let the GUI do it for you. I have a feeling y'all are going to choose option 2, which I'm okay with. Console is basically what you're printing to the screen. Console usually maps to a TTY. Oh, look, TTY. All right, terminal of a process, aka it's your terminal, what's being printed to a certain screen. We call them pseudo terminals now because they don't necessarily print to an actual physical screen. Dev null, this is my favorite device. All output written to this device is discarded. So if a program is being super annoying, you can just pipe its output to dev null and you won't ever hear from it again.
Oh.
If all of a sudden I'm not responding to your emails, this might be what's going on.
That's what he's doing.
I'm just telling you, just throwing that out there. All right, everyone good? Linux, everything's a file. Everything's a file, period. You got a file for everything. All right, compilation. So in this section, we're going to talk about how you compile your program. Y'all probably used to this with procedural, right? And in Java, you did the same thing. Now, in those environments, what did y'all use in procedural, actually? You used Atom? Okay, how did you compile?
Oh, I was about to say procedural. They changed the name of that, didn't they?
Oh, yeah.
I was about to say, I don't think I've taken that yet.
Yeah.
That's
It's
like,
okay.
Before OOP or before Java?
Okay.
I've used the, yeah.
You did with command line?
Yeah.
Great, awesome. So you brought it up to G++ and
Yeah.
ran it?
The whole big
Every
Yeah.
time.
Hmm?
The whole big line.
Oh, big one. Nice. All right, well, you'll be doing the same here, except we're going to try and make it easier for you. So GCC, so you compile. Did you ever do debugging, GDB or DDB? No. All right, so we can add a
They
debugger.
did that for us, I think.
Did that for us. Huh. How do you mean they did that for us? Who debugged?
So like, whenever I took it, like he had like with the Atom thing we did,
Mhm.
there was like a setting
Oh,
that you
cool.
could switch on that told you that debugged it for you every time you hit the play button.
Oh, okay, that's awesome.
Yeah, and it would be like, this is a line that's wrong, this is one that's wrong, and then all you had to do was fix the one line. Yeah.
Okay, so you can do that from command line.
Yeah. Sweet.
All right, then there's a program called Make, which is also one of my favorite programs because it's basically just used to call other commands. Valgrind will do memory analysis for you. You didn't have memory problems in procedural, did you?
No.
You will now. You will now. Oh, you will. And Valgrind will help you immensely on finding these errors. Also, another reason to learn this, use your program. I will take up to 10 points off if you have memory leaks in your program. Valgrind will tell you where these memory leaks are. So please use this program.
Plug the holes.
Yeah, plug, there you go.
Get it?
Plug those holes, nice. GNU plot, we'll talk about creating graphs, but we're not going to get to that today because that, well, if we get through all this, that'll be great. All right, so let's go and write an awesome C++ program, one that we are all used to doing. All right, hang on. Let me get into the correct directory. And class code isn't here, is it? All right, so I'm going to go into here and I'm going to copy our previous class code that we worked on. Now we're going to class code. All right, I call it compilation. We'll go ahead and open up, I don't know, hello.c. io.h int main. Oh, that's not how you spell main. There we go. Int argc char star argv printf hello world, and we'll give it a backslash in, sure. All right, so hello.c, we can gcc it. It does it. What just happened? Anyone remember? Compiled it. Well, what's the compiled file name? A.out. So it's ./a.out runs the program. All right. Awesome. I got disconnected from the network. Okay.
There's not much difference between being connected and disconnected.
If you do gcc hello.c-o for output to hello, what do you think that does?
Changes the name from A to hello.
Execute.
Changes which one? The
Execute.
executable name. Yeah, there you go. So now it's hello, it's hello world. Probably want to be using that. Oh. Huh.
No, sorry.
If you want to use debugging information, you need to pass the -g in. That's about all I can tell you right now. If you wish that this makes the file size larger, if you want it to be smaller, you can strip it. what am I talking about? Well, ls-lh, do gcc-g hello.c, output to hello. Notice that now it's 11K, as before it was 8K. But we can also strip it, and now it's down to 6.2. All right, doesn't really matter that much to you. Just keep in mind that -g will add debugging information, which will make more sense later on in this presentation. Oh, optimizations. Never underestimate how much optimizations will help you. You will be, I don't know, 3 to 15 times faster by adding a flag. Literally, instead of -g, you can do -o, and it compiles it with optimizations. Of course, the question here is, why would you not compile with optimizations? Can anyone take a guess?
It depends.
Does it depend on like the version of your compiler?
Okay. So if you compile without optimizations, it just spits the code out. If you compile with optimization, it gets the code and goes, okay, hold on, let me see if I can do something with this to make it go faster. Which one takes longer to compile? The optimizations. So if you just want to test it to see if something happens, you may not want to run optimizations. For this course, I don't see any program that's going to take a long time to compile. We're not going to get to that state. This is really useful for super complex applications. And actually, there's ways to get around it there as well. So you pretty much always want to have O. There are different levels, O2, O3, I think O5 and 7. I suggest sticking with 2. You may be confused, why don't we just up the level and make it max? That's a long debate about what's going on. Once you get to O3, it starts increasing your code significantly in order to try and do some advanced optimization techniques, which may not actually be beneficial, depending on your situation. In other words, just use O2. The kernel uses O2. Libraries use O3. It depends. Just stick with O2 for now. All right, so you can get error messages, and you can do -wall, which is my favorite. I don't know if I'm going to get anything. -wall. Hey, it didn't have a problem with that. Wow. Let me see. Should I give it an error? Actually, it still didn't have an error with that. Wow. Okay. C really doesn't care. All right. Warning all will tell you if there's any warnings. This will become this will be easy once we start coding. There'll be plenty of warnings in our code. All right, so that's a C program. Here's a C++ program. Actually, I'm going to copy it over so I don't have to type it again. Hello world. I'm going to take this command, cpp. I'm going to real quickly run this to show you it says I have no idea what you're talking about because I ran GCC. What I should have run instead is G++. And now we're good. Okay, keep that in mind. GCC is for compiling straight C, G++ is for compiling C++. For all intents and purposes in this course, you will only need to be using G++. We're doing good so far? All right, compiling multiple programs. Did you ever do that, or was everything always in one file? Always in one file? Oh, all right. Here we go. Let me open up hello.cpp. I don't know why I did MV when I meant that. I'm going to go and call this void say hello. All right. And then I'm going to open up, I'm going to main.cpp. I'm just going to have it int main, int argc, char star argv. Now really you only did one file, so this is all new, what I'm about ready to do. So if I cat hello.cpp, whoa, pp, say, oh, it's all lowercase. Let me fix that real quick. So the program here is say hello. It clears out, so we have cat main.cpp, looks like that. Well, cat hello.cpp looks like that. What do you think should happen when I compile both main.cpp and hello.cpp together? In other words, what do you think is going to happen when I do this?
Main would run first, hit say hello, and then it would go to void say hello, and execute what that says.
All right, that's what should happen, yes. It is not what happens. Say hello was not declared in this scope. We have a scoping problem in C++. See, we're already talking about code. What was scope?
Mouthwash.
Not what?
Mouthwash.
It didn't scope like where you can see certain variables.
Right. It's saying main cannot see hello, say hello because you haven't declared it. Main doesn't know what it is. How do you fix this? Well, we can open up main.cpp and we'll say void say hello, and we're just going to say that function is going to exist at some later date. Okay? So I'm going to clear this out. I'm going to cat main.cpp and then cat hello.cpp. Oops, let me clear that because I made that wrong. Main.cpp, cat hello.cpp. All right, so main is saying say hello is going to exist somewhere else, and let's go ahead and call it. Now when I compile it, it says, okay, cool. Let's run it. Now it runs. All right. Let me drive the next thing. Let's say, I know this is a very contrived example, but I'm trying to show you why we're doing things the way we are. So we'll go hello, hello. Say hello. I'll go twice. So I wanted to say hello twice, so there we go. I'm going to open up main.cpp. So if we want to call say hello twice, we want to do it this way. All right, let's go ahead and clear. Let me show you what I have. Kate, main.cpp, hello twice, hello, hello, .cpp, and then cat hello.cpp. All right, now the idea, of course, is I want to compile all of this together. All right, what should happen?
Say hello world twice.
That's what we want to have happen, right? Is it going to compile? No. Why do you think it's not going to compile? You're right, that's what we wanted to do, is say hello twice. Anyone tell me why this is not going to compile before it hit enter?
Because the void say hello twice wouldn't recognize say hello.
Right. Hello, hello, error, say hello was not declared in the scope. All right. So we have to go into say hello twice here. Whoops. Oh, not that one. All right, clear. Let me see if it'll let main.cpp, hello.cpp, and then hello, hello. All right, is it going to compile now? All right, I know this seems contrived, but I want to show you how it can bounce from one to another. Here's a very important topic, a very important feature that is hard to understand why we're doing it right now, but saves you oh so much time. Header files. Let's go hello.hpp. We'll say in here we have void say hello, and we'll have void say hello twice. That's the entire file. Okay? That's it. So we're going to go inside of main.cpp. We're going to include that file. And you don't use the less than or greater than sign, you use that. All right. Now I'm going to open up hello.cpp. Oh, we don't need it there actually. We need an hello.cpp. All right. Let me go ahead and clear this again. Oh boy.
You called it hello.hpp.
Thank you. That's fine. Oops, that's with an N. Good. That's all the files. Great. Clear this again. Cat main.cpp, cat hello.hpp, cat hello.cpp, cat hello. I know it seems contrived. Now, here's a great question. I don't need to compile the header file because notice the header file, by the way, HPP, header, C++ file, header file, doesn't actually contain code. It's just declaring certain things. When you include a file, it literally copy and pastes it into your current file. So in other words, it's copying those two hellos right where that include is. That is exactly what it is doing verbatim.
So in C++, we had to declare our functions at the top of the, so we were using Atom, it was all in one file.
Mhm.
So we would have to do prototypes for each of our.
Yes, you would.
So that's pretty much what this is.
Yeah, except for you're now putting it into a separate file.
And then including it into the file that you're using.
Correct.
Okay.
You got it. All right, now, so it's going to copy and paste that into main, and it's going to that's main, and it's going to copy and paste that also into hello, hello. What should happen? What should happen when you compile this program? Should it still function the way we want it to?
Yes.
All right, hopefully I'm leading into it. What's going to happen?
It's not gonna work.
It's not going to
We're
work.
gonna have an error.
Right. We're going to have an error. What's the error?
Probably a scope.
Scoping, kind of.
Maybe. Maybe not.
Oh, it liked it. Yeah, it doesn't matter. We're good. I thought there would be an error, but I think C++ has gotten nicer. Old version of C++ would tell you that you have done a redefinition of say hello. Because notice that in main.cpp, you have hello.cpp. You have both of these, and then down here you have both of those again. Some versions would give you issues. This version is not. I'm glad they've cleared that up. That's one less error you have to deal with. Hallelujah. Okay. Lastly, and then I'll go ahead and run it. Lastly, notice that we are compiling all the files together with this command. Each one individually. You do not have to, everything all is one. We do not have to do that. For example, if we just want to compile main.cpp, if we try to compile just main.cpp, it'd say undefined reference to say hello twice because we haven't included it in the list of files that we want to compile. But If we want to temporarily compile it, we can do -C. It took it. But what file did it produce? Produced a main.o file. So that is the compiled form of main.cpp. And we can do the same thing for hello.cpp. And we can do the same thing for hello.cpp. So we have all those .o files. Now, with those .o files, we can then finish linking them together, which is going to look exactly like the other command, except for you put in .o. The difference is that instead of actually compiling the CPP files, they've already been compiled because they were .o files, and now it's just pasting them together. What is the advantage of doing it this way as opposed to the other way? Think large project.
You can find out which one has an error.
Find which one has an error. That's great. That's beautiful. That's good. Error. Right now, you can always figure out which file has a compilation error. But what else? Think large project. If it took 30 minutes to compile everything, but you only made a change to one file, now you only have to recompile your one file and then link it together. And just so you show that it works, hello, hello. All right. I need to let you have lab time. So we're not going to be able to get to this. That's okay? Darn. All right. Before I go into it, does that look very tedious, typing all those commands out?
Yeah.
It does, doesn't it? Guess what tool we're going to learn that'll make it easy so you don't have to type all these commands out? A makefile. And that's coming up next. I'll let you, think about that over the weekend so you can't wait till Monday comes up to learn about makefiles.
Now we don't have to do lab 2, right?
Well, you can get started on it.
But are you officially assigning it?
Yeah.
Yes,
You see, there's a lot of stuff that I just don't think we know about.
that's true, you don't. Okay, we did get a rough start. I'll give you a little extra time on this one. But you're going to regret this in the long run.
So when was this one supposed to be due?
A week from today.
And is
It'll be a week from Monday. We got to catch up at some point. But I understand you need some extra time.
Let this all sink in.
This is, I'm assuming y'all haven't done this before? How many of y'all have done this before? Let's ask that question. Right, okay. So, if you haven't done this before, it's going to take you a little while. Get started now. Look at Lab 2 over the weekend. Try to do some part of it. You will be able to at least figure out a part of it, aka how do you compile something and type that command in. Because this is just something that takes a while for it to click together. Okay, guys. Y'all have, I don't know, 45 minutes for lab time, so I need to make sure y'all have lab time today so I can answer any questions. Anything else? All right, guys, I think we're doing great. Get your labs in so I know that you are doing